Okay, let's dive right into this explainer and unlock the ultimate Cambridge computer science mastery strategy for data validation methods. Specifically, we're going to completely deconstruct limit checks and check digits. Look, it doesn't matter if you're studying across syllabuses 0417, 0478, 0983, 0984, 2210, or if you're specifically tackling the Advanced AS and A-Level 9618 paper, what we are covering today is absolutely 100% essential. Mastering data validation is completely non-negotiable for Cambridge computer science success. Why? Because this topic appears in virtually every single examination series. You literally cannot hide from it. But here's the thing. Instead of just sitting here and memorizing textbook definitions like everyone else does, we are going to look at exactly what the examiners are desperately searching for in your answers. We are going to build bulletproof arguments. We're going to use stress-tested evidence. Think of this explainer as your personal quality control system for your exam paper. So grab your notes, get laser-focused, and let's decode the examiner's mind. Our study plan today maps exactly how we are going to transition your answers from basic, entry-level theory to advanced, top-tier exam application. We'll start with the validation challenge, move into the procedural framework, break down the top examiner mistakes, run through a quick interactive workshop, and finish up with the evaluation strategy. Let's kick things off with Section 1, the validation challenge. To really understand this challenge, I want you to imagine two typical students sitting down to a real Cambridge computer science past paper question, let's say past paper code 9713, dealing with a highly complex sensor system. First, we have Alex. Now, Alex knows his stuff, but he overloads his answers with raw, unfiltered computer science facts, completely failing to provide any actual analysis of how those facts apply to the specific system in the question. Then we have Sam. Sam rushes. Sam completely ignores the specific command word in the prompt and just throws down a totally generic solution. And guess what? Both of them lose massive points, despite actually knowing the underlying theory. So I want to pose this high-stakes question to you to really frame the antagonist of our explainer today. Why do students find applying concepts to unfamiliar contexts so incredibly hard? You see, Cambridge doesn't just want to know if you can define a limit check. Anybody can do that. They are going to throw an entirely unfamiliar context at you. Maybe it's a drone's altitude sensor, maybe it's a temperature control system in a nuclear reactor, or maybe it's a highly specific inventory tracking algorithm for a warehouse. The friction happens when your brain tries to retrieve a memorized fact, but you don't have the analytical framework to map that fact onto a weird, unfamiliar scenario. You freeze, and when you freeze, you default to generic answers, and generic answers get 0 marks. The difference between these two approaches brilliantly illustrates superficial breadth versus analytical depth. Superficial breadth is essentially writing down everything you know about validation in a giant, unstructured, panicked list. It's writing something like, a limit check ensures data is within a specific range. I mean, sure, that's true, but the Cambridge syllabus explicitly emphasizes that top-performing students must exhibit connected, conceptual understanding that actually transfers to the problem at hand. Analytical depth, which is exactly what Cambridge demands for top marks, sounds entirely different. It looks like this. A limit check is implemented here to ensure the drone's altitude input remains strictly between 0 and 400 feet, preventing integer overflow errors in the altitude processing algorithm. Do you hear the difference there? It is night and day. It's not just knowing the tool, it's demonstrating precisely how, where, and why that specific tool operates in that exact environment to prevent a catastrophic system failure. So how do we actually build that depth? That brings us to Section 2, the procedural framework. But before we continue, subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into the strategy that top students use to perfectly structure their answers. Enter the PEEL framework. Point, evidence, explanation, link. Look, the Cambridge assessment objectives for data validation methods target 3 very distinct cognitive domains: knowledge, application, and analysis. And the PEEL framework forces you to hit all 3 of them every single time. First, you state your point. For example, a limit check is the most appropriate validation method for this sensor. Second, you provide evidence pulled directly from the scenario, because the prompt explicitly states the chemical reactor temperature must not exceed 50 degrees Celsius. Third, you deliver the explanation. This algorithm will instantly reject any input value above 50, preventing system overheating and potential hardware damage. And finally, the link.
This is where you bring it all back to the core questions command word to show the examiner you fully satisfied their prompt. When you use peel, you aren't just guessing anymore. You are naturally engineering logical, structured, undeniable reasoning. The most crucial takeaway here is that this standardized sequence unlocks what we call the method mark strategy. Top candidates use a rigorous 4-step algorithmic approach to answering complex questions. Step 1, identify the key elements of the context. Step 2, apply the relevant principles, whether that's a limit check or a check-digit algorithm like modulo 11. Step 3, execute your analysis with incredibly clear step-by-step working. And step 4, verify your results. Examiners actually want to award you points. I promise you they do. In computer science, practical application means showing you're working. If you have to design an algorithm for a check digit and you clearly lay out the weights, the multiplication, the summation, and the division by 11 to find the remainder, and you write out those steps clearly, the examiner can give you method marks for your systematic process, even if your final arithmetic has a slight error. You are being graded on your algorithmic thinking, not just the final destination. Now let's transition from what you should do to what you absolutely must avoid. Section 3, top examiner mistakes. I need you to listen very closely to this because this is straight from the source. Examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. I literally cannot emphasize this enough. If you write a beautiful, technically flawless, half-page paragraph explaining the intricacies of the modulo 11 method for a check digit, but you never once mention the specific barcode system or the product IDs or the shipping crates mentioned in the past paper question, you will get 0 application marks, 0. Failing to contextualize a limit check or a check digit algorithm will absolutely destroy your mark potential. The examiner wants to know you can solve their specific problem, not just recite a textbook definition you memorized the night before. We've actually analyzed and pulled the top 3 mistakes straight from Cambridge Principal Examiner reports so you don't have to. Mistake number 1, using the wrong formula or algorithm entirely for the given context. This happens all the time when a student confidently proposes a length check when a limit check was blatantly required by the numerical data type in the prompt. Mistake number 2, ignoring boundary conditions and edge cases. Oh, this is huge for limit checks. If the valid range for an input is 1 to 10, students constantly forget to specify whether their pseudocode uses less than 11 or less than or equal to 10. You have to be mathematically precise. An examiner will dock points if your logic allows an invalid edge case through. And mistake number 3, which we just covered, answers lacking scenario specificity. If you can memorize these 3 traps and actively check your answers for them, you are already miles ahead of 80% of the candidates taking this exam. Section 4, interactive workshop. But stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's put your skills to the test. We are going to do a rapid-fire Find the Flaw challenge. I want you to consider this exact statement written by a student. A check digit validates the data is correct by recalculating the modulo 11. I'm giving you a mental 30-second timer here. Spot exactly why this sentence loses marks based on everything we've just learned about generic, flawed answers. Think about the specific terminology being used. Have you spotted it? Okay, the massive flaw here is the phrase validates the data is correct. Listen, a check digit does absolutely not verify that the data is factually correct or truthful. It only validates that the string of numbers hasn't been corrupted, transposed, or accidentally mistyped during data entry. If I type in a valid product code, but it's the wrong product, the check digit will still accept it. Validation is not verification. Plus, this sentence is completely devoid of context. To fix this disaster, you need to use the PEL framework, clearly specify that it catches transcription errors, and link it heavily to whatever specific data transmission scenario the exam provided. Now let's step up to the highest order of thinking. Section 5, the evaluation strategy. When you get to the end of a paper, the command words change. They start asking you to compare or evaluate. For instance, evaluating limit checks versus check digits. The trick here is that you cannot just write 2 separate paragraphs defining each one independently. That's not an evaluation. Comparative analysis requires actively identifying similarities and differences simultaneously. You must use comparative connectives. You want to write something like, both limit checks and check digits are proactive validation methods designed to trap errors upon initial data entry. However, whereas a limit check restricts data to a strict numerical boundary,
A check digit utilizes a mathematical algorithm, like modulo 11, to ensure the structural integrity of a barcode. You then support each of those claims with evidence, maybe showing a quick calculation or referencing binary data limits, and you draw a definitive conclusion about their relative importance to the scenario. That is how you secure top marks. If you truly want to master unfamiliar contexts, you have to lock in this 3-step problem-solving algorithmic thinking methodology. Step 1. Deconstruct information. You rip the exam prompt apart into logical pieces. What is the exact data type? What are the physical constraints of the hardware? Step 2. Solve systematically. Apply your limit check logic or your check digit algorithm step by step, showing absolutely all you're working to secure those method marks we talked about. Step 3. Evaluate and check for reasonableness. This is where you look at your final answer and seriously ask yourself, does this actually make sense for a nuclear reactor's temperature sensor? Did I consider the processing trade-offs? Did I acknowledge the limitations of this validation method? Top-scoring candidates always justify their decisions with solid evidence. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. It's about shifting your entire mindset from passive memorization to active algorithmic application every single time you sit down with a past paper. Let's quickly recap the 3 ultimate rules, your computer science success blueprint that will guarantee top marks when analyzing limit checks and check digits. Rule 1. Command word decoding. Always tailor the depth of your answer to whether they are asking you to state, describe, or evaluate. Rule 2. Peel framework application. Never leave a point unexplained or unlinked to the highly specific, unfamiliar context of the question. And Rule 3. The time management matrix. Please do not spend 10 minutes writing a superficial novel for a 3-mark question. Spend your time engineering a concise, analytically deep, step-by-step algorithm exactly like we practiced today. So, the next time you are faced with an entirely unfamiliar system on an exam paper, whether it's a drone sensor, a retail database, or anything else Cambridge throws at you, ask yourself, are you just reciting facts and hoping the examiner connects the dots for you? Or are you engineering a bulletproof, contextualized algorithm? The difference is your final grade. Here's your final reminder, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, keep evaluating, and I will see you in the next explainer.